Um, yeah, so my name's Joe. I was a Northcoders graduate late July, August last year, along with Eddie, who you probably know, upstairs. My talk this evening will involve, it'll involve some command line stuff, it'll involve some JavaScript, it'll involve me typing while standing up. The propensity for disaster is huge. I'm going to start by doing something that hopefully won't go wrong. We're just going to look at a website. Okay, is that all right? And the website we're going to look at is one that I hope might be quite useful for you. And it's produced by your neighbors here in Federation House, ThoughtWorks. And it's called the Technology Radar. Now, for those of you who are going to go to interviews and have to answer questions about technology, this could be quite useful. A couple of times a year, they produce this digest of new technologies and what they think of them. And they split these technologies up into various groups, like languages and frameworks, for example. And there you go. They split these languages and frameworks they split their categories into various groups, like hold, which means we're not too bothered about this. Assess might be interesting. Trial, this looks really interesting, you should be thinking about using it. And adopt, which means, yeah, really use this. Okay? So up there we see stuff like Kotlin, which is a new version of Java, which might be quite interesting to know about. Are you guys already using Jest for your testing? Is that, yeah? Okay, so Jest is up there. You're right on message. You're in there with ThoughtWorks. Everything's great. Okay, so that's all. That's brilliant. I'm going to look at platforms. And I'm going to point to something that's right in the middle there in adopt. And it says something about Kubernetes. Oh, if you know something about it, and I'm not giving this talk, because I know not that much about it. Let's see if we can find out a little bit about Kubernetes on here. So, since we last mentioned, Kubernetes has become the default solution for most of our clients when deploying containers into cluster machines. The alternative engine, container orchestration platform of choice. You might well read that and have absolutely no clue what Kubernetes is. I think a few months ago, I might actually have been in the same condition. So I have modest goals. We're going to try and understand what a container is. And then we might think about what would happen if you orchestrated containers. So let's start off by looking at maybe the sum total of all of my Northcoders knowledge. Whoops, not there. In there, okay? This is about all I learned at Northcoders, right? How to write a server. Now, this is a particularly simple server, but you know, it should work. And you know, I can show it to you, and we could show it to you, but I've done a bad thing. And the bad thing that I have done, I have uninstalled Node from my computer. Harriet is shocked and horrified because she can't conceive of a world in which people don't have Node on their machines. Now, we could solve this fairly easily. I could brew install Node, but that would be far too easy. Okay? We're going to do this in an unnecessarily complicated way. Okay? And to do that, I'm going to use something called Docker. Okay? So Docker is a containerization service. And it does lots of things. So I'm going to, you know, there's all the things it does. I'm going to use one of these very useful commands. I'm going to docker build. I'm going to give it a little name. Let's call it node nc. And while that should work, I think. Oh, I need to put in a dot because it's this directory. Yeah. While that's working, I'm going to waffle. So, what's a container? You might know what a virtual machine is. Okay? So if you've, particularly if you've got a Mac, you might be aware of this thing, Parallels, where you can run, say, Windows on your Mac machine. So a virtual machine is another computer that runs inside your computer. And it's kind of totally separate from what you're doing. You run a piece of software that emulates another computer inside yours. Containers are kind of similar. But a virtual machine is a big, heavy, resource-hungry piece of software that is a general-purpose computer within your computer. A container is a single-purpose computer within your computer. And what it does is it runs one app. That's all it does. It runs one app. And what we do is we think about all the dependencies that we need for that one app. What do I need in order to run Node? Well, I need a computer with an operating system. Let's say Linux. That's kind of easy. I need a copy of Node. That's about it. Okay? So what this container will do is that we'll create a computer within my computer that has just a basic copy of Linux and Node. Okay? So how does it do that? Well, alongside my highly complicated server, I have something called a Docker file. And this is a recipe for this little computer inside my existing computer. Let's go through the recipe. The first thing it does is helps me avoid all the hard stuff. I don't have to create a recipe for Node or Linux. I can go get one in true Blue Peter fashion like somebody has prepared earlier. Okay? And to do that, I'll go to Docker Hub. Now, Docker Hub has lots of stuff on it. It's like GitHub for Docker. But it's got lots of stuff there. Nginx is a very popular back-end web server. So is HTTPD. Redis is a caching database. These are all pretty. Ubuntu is something that probably many of you've got on your own computers. MySQL, Postgres, and down there near the bottom, Node. Okay, so we've basically pulled in one of the many versions of Node that are in Docker Hub. And that version of Node contains not just Node, but the operating system required to run it, which will be a simple, stripped-down version of Linux. So, back here, I now can do Docker run. I'm going to make it in a detached process, and I'm going to bind. Oh, actually, so we should go through our recipe because we're not quite finished. I've pulled in my copy of Node. I've created a little directory inside this copy of Linux that I've got working inside this. I've copied package.json in there. I've done my npm install because we have to do that. I've copied everything else into that directory. I've made a port inside this little computer, and then I've said every time you run npm start, and my package.json says that npm start in this case is run the server. Okay, so that's my recipe. This thing runs one application, which is make my server. So let's see if we can do that. We'll do Docker run port. I need to bind a port to the port that I have got inside my machine. Docker run, and it's called, actually, before I do anything else, I'm going to do, see what it's, Docker, whoops, list, sorry, Docker image, ls. So I now have a copy of Node, and now have, which is the NC up there. So I'm going to take this image, I'm going to say Docker run -d -p 8080 8080. I'm going to refer to that. Ooh, something's happened. So let's see what's going on there. We'll go to a browser. We'll go to our good old friend localhost 8080. And there we are. Now, people, yeah, I need that round of applause. The people who know me from my time at Northcoders will know that this is the very edge of my front-end capabilities, right? I made it a H1, and I put in 3 exclamation marks to make it quirky and interesting. So that's it. That's as good as it gets. I'm a back-end kind of guy. Right, now, so there we have our server, right? And some of you can serve out much more ambitious stuff than I'm ever likely to. So, great. We have a Docker working image. Now, this image is stored within my computer. It's once I've got it, I can call it any time. So all I need is Docker to be installed in my computer. Let me just point out that I have not installed Node on my machine. Node still does not work on my machine. What I have done, let's just try this. This might work if I'm lucky. Docker exec, I'm going to have to put in a little command line option. Docker exec, yeah, that should work. Let's try this, yeah. Oh, no, what did I do wrong? Container command, oh yeah, that was it, forgot the command. So let's do that again. The container is right, so I'll do that. And the command was Docker. Yeah, that's it. Sorry, container and image getting mixed up. That's not me. So, told you this would be a disaster. Right. So, this is Linux within my machine. Okay? So there's this tiny little computer running within my machine, and I could do all the things in here if I needed to. So, you know, guess what? I have all the stuff that I had in my machine inside this little virtual machine inside my computer, all of which is very nice. Now, why? Why not just do brew install? Well, couple of answers to that. Let me just go back up here. So I work at AutoTrader, and I sort of mainly do sort of data stuff. You can get Docker images for considerably more complicated things than just a copy of Node. And for example, this thing Kafka, which you see a couple of references to here, is a horrible, messy back-end system for helping servers swap data between each other. It has no business on anybody's laptop. But if I'm writing code for it, sometimes I need to have a fake copy of Kafka. So this provides it. I don't have to go through 20 lines of setup and downloads and all sorts of nonsense. I just run my Docker image, and there's a fake Kafka running on my machine that I can test stuff with. So that's one use. Much more importantly, however, is think about where you deploy your applications to. You're not going to be deploying your applications to a laptop. You're going to deploy them to a data center or the cloud, as Harriet is finding out. She now lives in AWS land, along with the rest of us. So how do we do that? Well, you could, trudge down to your data center, find a rack of machines, download a load of data and software onto the machine, and from then on, refer to that machine every time you need your application. So let's say I need to serve out my, very impressive website. I've got a machine, it's got all the server stuff on it, and people will hit an endpoint to that machine every time. But actually, what's much better is you just have a data center full of machines with Docker on them. And you use your machines for whatever you want. So we're going to use these 5 machines today to serve out the web server. We're going to use those 5 machines for MySQL database. We just send down Docker images, and we don't need to do any special setup within the computers themselves. They just accept the image and run the image in the data center. When we're tired of it, we take down the Docker image, we stop the Docker image, and we put something else there. So we no longer need 10 web servers, we need 10 databases. We'll take down those 10 10 web servers, we'll put 10 databases there instead. So it's a really convenient way of dealing with getting software onto lots of production machines, and it's becoming really useful. It has one shortcoming. By their nature, these containers are self-contained. They operate well as a little sort of independent fighting unit. Okay, so I have a thing that now operates really well as a web server. But suppose I wanted my web server to interact with a database. Suppose I wanted, let's say, to have, let's say my brilliant idea for a web page explodes and I have to have 1,000 servers serving out this web page. How do I load balance between those 1,000 servers? In short, how do containers talk with each other, and how do they talk to the file system and the databases that they need? And that's when things get complicated, because the solution to that that's arising is what Kubernetes is. And Kubernetes is pretty complicated. It's so complicated that I couldn't figure out a way to run any kind of copy on my machine. It's so complicated that I can't take you to the AutoTrader copy of Kubernetes, which is on Google Cloud Platform, because I'm not even allowed to get into it on the VPN, and I'm not really qualified to do anything there when I do get there. But essentially, Kubernetes has this concept of pods, which are containers for the containers, but add on a layer of communication between those containers and allow you to replicate them really easily, refer to them with other programs so that you can spin them up, take them down, and get them to talk to databases and all of that sort of thing. So that's what it is. If you ask me how it works or how people do these things, the answer is I'm not terribly sure. I've seen a screen like this, and I've seen people spin up containers, and I've seen people put pods in there. But Kubernetes is a fairly complicated piece of software, and I'm still getting to grips with it. But at least you now know what Kubernetes is. If you don't, maybe you know what Docker is. And if you don't, maybe you know about the TechRadar website, which might be useful.